Here we are at example 2 from our 0.3 set of notes. We're asked to solve the following variable. We notice that we're trying to get k all by himself, and we have a bunch of different fractions over here. So we talked about that thing with the LCD, which in my opinion is pretty much, it's not quite the same, but for the sake of our class for right now, it pretty much is the same thing as our LCM. And when we're looking at the least common multiple, we're referencing the denominator. So we have 4 on the bottom here. Really, this is -5/1. That's the denominator. We have 4 again on the bottom, and then also -1/1. So the smallest thing that 4, 4, and 1 go into comes out to be 4. Now, the whole reason why we actually care about the LCD or the LCM is because that's the number that we're going to go ahead and multiply on both sides. Because when we multiply that number, that magical number 4, every single fraction will end up dropping out and canceling, and that's kind of like a good thing. We don't like fractions if we don't have to deal with them. So distributing our 4, we have 4 times 3 is 12/4k. And then when we distribute the 4 times the -5, we end up with -20/1. Remember, we just keep the denominators just as they are. And the reason why we keep the denominators, by the way, is when we're multiplying it by this LCD or LCM, 4 is the same thing as saying 4/1. So really, if we multiply 4/1 on both sides, 4 is being multiplied by the 3, but on the bottom we have 1 being multiplied by the 4. And that's why we'd still have that 4 there. Likewise over here, when we distribute that 1 to this one, we still have that 1. Okay, so there is stuff even happening on the bottom, but that's kind of just behind the scenes a little bit. Now, on the right side, 4 times 1, we end up with 4. And again, on the bottom, that 4 times that 1, we get 4. 4 times -1 gives us -4. And then on the bottom, the 1 times the 1, we just get 1. Again, you don't necessarily have to show this bottom piece. I'm just kind of showing it for the algebra and the effect of it. That is math that is still happening there. Now, simplifying things up, we end up with 12/4, well, that's 3k, minus 20/1 is just 20, equals 4 divided by 4, well, they just cancel out, leaving us with 1k. And then -4/1 is just -4. So, notice we don't have any more fractions. That's a great thing. We don't like fractions. So, let's get all of the k's on one side. And in order to do that, what we do to one side of the equation, we have to do the other. So, we'll go ahead and subtract 1k from both sides, leaving us then with a total of 2k's on the left side, minus 20 equals -4. Well, now we want to get all of the numbers on one side and k's on the other, so this -20 doesn't really have anything to do with the k, so we're going to go ahead and add that to both sides. Just keep in mind, it's -20 right now. So once we do that, we're left with the 2k on the left side. The -20 cancels out with our +20, so that's gone. Equals -4 plus 20 comes out to be 16. And now again, we want this k all by himself. It is stuck and glued by this coefficient of 2, so we're going to go ahead and divide that coefficient on both sides. 2's end up canceling out, leaving us with just the k that we were hoping for, equals on this side 8. So our final answer comes out to be 8. Now, there is a little bit of a shortcut that I definitely just want to discuss really quick, because some people really like these shortcuts. In fact, we may have already talked a little bit about it in class, depending on the year, but I definitely want to show it really quickly. So, it does have to go back to when we were picking the LCD/LCM and when we were distributing that item. So, once we get everything, there we go. All right. Let's go ahead and, well, we won't even worry about the bottom because I think you guys can probably see the bottom being multiplied there. So let's just go ahead and focus on the top number being multiplied with 4. Now, if we go ahead and distribute this 4 right here, and we notice at the bottom is also 4, we can ask ourselves, how many times does 4 go into what we're multiplying by the LCD or LCM 4? Well, that goes in one time. 4 goes into 4 just one time. And then that 1 that's left over is going to be multiplied by our numerator, the 3. So 1 times 3, we get the 3k. Well, we're still distributing that 4, that original 4, to the negative 5. And the same thing still plays. This bottom number 1 goes into 4, not one time, it changes a little bit, but 4 times. Again, 1 goes into 4 times, but then that 4 is being distributed to the negative 5, that numerator piece. So then that just comes out to be negative 20. On the right side, we have 4 being distributed to the 1 over 4. Well, 4 on the bottom goes into 4 one time. So we're left then with the numerator 1 times the 1, giving us 1k. And then likewise, when we distribute the 4 to the negative 1, this bottom number 2 goes into 4 times. Multiplying that numerator negative 1 times 4, we end up with negative 4. So it's really, I mean, it's kind of just like swapping the order of it, but the reason why that's a good shortcut is then you're actually dealing with smaller numbers up here that you're distributing and multiplying by all of our numerators. So it does have a small advantage, but you know, if it's a little hard to see, don't worry about it. You can just multiply the tops and then divide by the bottoms like we did with the previous one. But notice we end up still, as long as all of the algebra is correct, with the same result as we did. It's kind of just skipping a quick step. So again though, that is example 2 from our 0.3 set of notes.